it is a matrix match type of question here. In question number 16, a sound wave is traveling in air along positive x direction. Displacement s of the medium particle is plotted against x at the instant shown. If P0 is the mean pressure and delta P0 is the pressure amplitude, then match the characteristic of point mentioned in column 1 with the column 2. Here in column 1, we are provided with some points where the characteristics has actually been asked and the respective answer is actually given in column 2. Well, as per the situation given here, I would just redraw the diagram. Let this point being A, this is B, this is C, and this is D, and further on I would say. Definitely the point A, from this point onwards the displacement is positive, and at B it is maximum. So particle has actually displaced along this direction. It is maximum here, and finally it becomes 0 at point C. From C onwards the displacement is actually in negative side, and it becomes maximum at point D. So from here onwards it will be along this direction. Looking onto this picture, at least it is very much clear that at point A all the particles are shifted away from the point A. So here we shall have the pressure minima. Similarly, on point C all the particles are towards the point C. So at this point we shall have the pressure maxima. Well, let us start with option A here. At point A, pressure is actually lower than its average value, or it will be on the negative extremum. So pressure at A will be P0 minus delta P0, delta P0 being the amplitude, pressure amplitude. So Q will be the matching answer here. Other part is, at point A the particles are at their mean position itself, so they shall have the maximum corresponding velocity at this point. So I would say the speed of particle is maximum at point A. Same argument will be given for the point C also. Remember this one. Okay. Now let's proceed to option B here. For option B, this is the point B here. It is actually at the maximum displacement, so the speed will be 0, or in fact the speed will be minimum, I would say. So particles speed will be 0. This is the one that will be matching answer here. And the other part would be, since this point is actually at the maximum displacement, so the pressure here will be at its average value. So I would say this point will be corresponding to the pressure of P0 itself. So it will be matching with P. Point C, well, I just mentioned the speed here will be maximum, but the pressure will also be maximum. Maximum in the sense it will have the maximum positive shifting from the average value. So R will be correct match for this one, and S, that is the speed of the particle, is maximum will be the correct match here. At the point D, yet again the pressure will be at its average value P0, that means P will be the correct match, and the speed of the particle on the similar basis as we gave the argument for the point B, it will be how much? 0. So T will be the correct match here. So what we got here for question number 16, with option A, Q and S are correctly matching. With option B, P and T are correctly matching. With option C, R and S are correctly matching. And with option D, P and T are correctly matching. That's the answer for question number 16. Now let's proceed to question number 17. Here in question number 17, a diatomic gas is undergoing through a process A to B as mentioned in column 1. Match the entries in column 1 with the entries in column 2. All symbols have their usual meaning. It's been given the gas to be the diatomic, so I'm just writing here the CV value to be 5 by 2R and CP value to be 7 by 2R. I'll be using this value whenever required. For option A here, the graph is in terms of pressure and volume, and it is very much clear here that P divided by V is coming out to be constant here. So definitely I'll write this equation as PV to the power minus 1 is equal to constant, and in that particular term what we write here as the specific heat capacity would be how much? C is equal to CV, that is 5 by 2R minus R divided by N minus 1, N to be taken as minus 1 and minus 1 it will be minus 2, so here it is 2. So it is 6r divided by 2, effectively it is coming out to be 3r. Just look which one of the option is matching here. T is the only option, so A is matching with T. What about here in the B option? It is P divided by rho. Fine, P divided by rho, that is coming out to be constant. 1 by rho will be actually how much? It will be proportional to V. So PV is coming out to be constant. This is the standard isothermal case, I would say. So definitely for the isothermal case, the molar heat capacity is not defined for the process. P will be the matching here. And the other part is process is isothermal compression. Let's see if it is compression or not. Density is actually increasing. That simply means the volume is decreasing. So well, R is also the correct match here. Now for the option C, the graph shows that the temperature is actually increasing along this direction, and the other part is sigma T is equal to 1, where sigma was given to be how much it is? It is 1 by V dV by dt into T, that is coming out to be 1. So I'll just write for this particular equation here, dV by V would be equal to dt by T, or writing these two part in one side itself, I would say it is ln V minus ln T is equal to constant, or V divided by T is equal to constant. Writing down T is equal to pressure and volume, I would say V divided by PV is equal to constant, or actually P is equal to constant. So this process is the representation of isobaric process. So molar heat capacity would be how much? It is 7 by 2R. So I would say Q will be the correct match here. Another part being process is isobaric expansion. Well, let's see if it is expansion or not. I just mentioned the process being the isobaric and the temperature is increasing. So definitely the process will be the isobaric expansion. So Q and S will be the correct match here. What about the last option, that is option D? V divided by T is coming out to be constant. V divided by T is coming out to be constant. From the standard ideal gas equation, we shall say that PV is equal to nRT, or V divided by T will come out to be nR divided by P. Since it is coming out to be constant, that means pressure is constant here. So the molar heat capacity would yet again be, it is 7R by 2, or Q is the correct match. What about for the process, whether it is expansion or compression? Yet again we find the temperature is actually increasing and it is isobaric, that is confirmed. So I would say it is expansion itself. So QS will be the correct match. So here we are getting for question number 17, A will be matching with T, B will be matching with P and R, C will be matching with Q and S, and D will be matching with Q and S. That's the answer here. Now let's proceed to question number 18.